All right, guys, are there any questions over any of the assignments thus far? Okay. 9.4. It might be helpful to get. Yep. Yeah. I'll borrow it for a second. Right there. Yep. Okay. All right, guys. So we're looking at problem number 6 first. So we have side lengths of 3 and 5. And the hypotenuse is the square root of 34. J, L, K. And we want to find the tangent of the two angles, the two acute angles. Number 6. So we're finding tangent of angle J and tangent of angle K. Now, tangent is opposite over adjacent. So for angle J, the opposite side is 5. The adjacent side would be 3. And this here would be 1.6667 as a decimal. Now K, the opposite side is 3. The adjacent side is 5. And this as a decimal is 0.8. That's good. Any questions on this here? Now, number 11 has a triangle, D, E, F, 12, 35, and 37. Now, they said tangent of angle D is equal to 35 over 37. Describe the error in the statement of the tangent ratio. Correct the error if possible. Otherwise, write not possible. So 37 is the wrong number. Yes, because for angle D, they did take the opposite side, but they also took the, yes. So it should be 35 over 12 is tangent of angle D. That's it. So you need both, that 37 is the wrong number, kind of explaining why, and correcting it. Now what we're looking at today is this here first, inverse. Sine inverse. In the calculator, sine inverse, cosine inverse, and tangent inverse are the buttons right above sine, cosine, and tangent. So to be able to use those, we hit second sine to get sine inverse. To get tangent inverse, we'd go second tangent. And the same for cosine inverse. Now we can use these here. And the first one we're going to calculate, the first one we have here is sine inverse of sine of 74 degrees. Now we can take the calculator and go second sine inverse of sine of 74. And we can type it in and let the calculator tell us what this would be. Second sine. So it works out that sine inverse of sine of 74 is 74. If we look at cosine inverse of cosine of 21.5, cosine inverse of cosine of 21.5, we get for most of them, yes. For what we're going to work on, yes. And tangent inverse of tangent of 58 it is indeed 58. Now there are some exceptions that we do have for this here. So if we said took sine inverse of sine of 98, we get 82. So if we go outside of 0 to 90 degrees, they don't match up. But for what we're doing, because we're only focused on a triangle, angles between 0 and 90 degrees, they are going to be the same. They undo each other. These are inverses. They cancel each other out. And we have this here, and we can use this inverse function to undo sine, cosine, and tangent. Now, the reason that this is helpful, we're not going to go too much into those definitions, is that they're helpful with this here. Because if I want to find the angle A, so for tangent of A, if I want to know what the angle is that gives us a tangent value of 75, we can use its inverse. Because tangent inverse of tangent of A, as we just saw, is going to give us what? Just that angle A. But what we do to one side, we have to do to the other. So we're also going to take tangent inverse of 0.75. And at this point here, we can type it into the calculator. So round to the nearest tenth, which would be 9. Questions on this so far? Let's look at the next one. Sine of B is equal to 0.87. So what we can do is apply sine inverse to both sides. Well, sine inverse of sine of B is just B, which will tell us B is equal to sine inverse of 0.87. And in the calculator, we can do second sine inverse of 0.87 and get 60.458, or if we round to the nearest tenth, 60.5. So this gives us a way to find the angle. What angle, if we plugged it in, would get us back to our decimal point. And the last one, here we would apply cosine inverse to both sides. And the inverse that we pick is really dependent upon which trigonometric function is being used. We use sine inverse for sine, cosine inverse for cosine, and tangent inverse for tangent. If we plug this in the calculator, second cosine inverse of 0.15, we get 81.4. Questions on any of this here? Are you ready for the next one? So for the first one, tangent of A equals 3.92. What would we do? Right, we would apply tangent inverse to both sides. Because tangent inverse of tangent of A, the tangent and tangent inverse will cancel each other out. They will undo each other. 3.29. Questions on this here? Okay. Yeah. So for this here, we applied tangent inverse to both sides because tangent inverse of tangent of A is going to give us A, the angle by itself. So if we take tangent inverse of one side, we have to do it to the other, 73.1. Questions on A? What would we do for B? Yes, since we have sine of B, we're trying to find angle B. To get the angle away from sine, we have to use sine inverse. And if we apply it to one side, we have to apply it to the other. Now, sine inverse of sine of B is going to simplify to just B. Now, at this point, we can plug in sine inverse of 0.55 into the calculator and get And lastly, we're going to do the same thing with cosine. So we're going to apply cosine inverse to both sides. So cosine inverse of cosine of C is going to equal cosine inverse of 0.87, letting us know that angle C is Any questions on this here? Questions on this here, finding the angle for these here. Okay. Now, we can still use this to find the missing angles in the triangle. Because using sine, cosine, tangent, we can set up these proportions. The sine of a given angle is opposite over the hypotenuse. Cosine of a given angle is adjacent over the hypotenuse, and tangent of a given angle is opposite over the adjacent. Now looking at this here, we do have two sides that are given, yes? What? Because we're told two sides of the triangle, 2 and 3, but we don't know what the third side is. So can we still find it? Because we could use sine, cosine, or tangent to find it, or we can just use Pythagorean theorem. Because for that there, C is the hypotenuse, which we're trying to find. A and B are 3 and 2. At this point here, 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. Square root both sides. C is square root of 13. Any questions on how we found the third side? We good with finding the third side of the triangle? Yes. Now we do need to find the values of A and B. So we found side length C. Now we need to find angle A and angle B. And we know that all three of these angles will add up to be 180. Which angle do we want to find first? A. We can go with A. Now, we need to determine if we want to use sine, cosine, or tangent. So if we are going to use sine of A, we need the opposite side in the hypotenuse. Do we have the opposite side of angle A? Yeah, so the side opposite of angle A is 3, and the hypotenuse is square root of 13, yes? If we wanted to use cosine, do we have the adjacent side to A? And we still have the hypotenuse. And tangent, we need opposite and adjacent. Do we have all three pieces of information? So does it really matter? No. We just need to pick one. So we can pick sine of A is the opposite side length, which is 3 over. Now to get the angle, what do we have to do? We have to apply sine inverse to both sides. We have to apply sine inverse to both sides. It's the same thing we were just doing, but instead of having a decimal, we now have 3 over the square root of 13. Here, sine inverse of sine of A is just A. Now, in the calculator, we can go second sine inverse fraction. 3 over second square root of and we get this here. So rounding to the nearest tenth gives us 56 point. So the measure of angle A is 30 degrees. Questions on this here? Now we do need to find angle B. Yes. So we can add 90 and 56.3. We get 146.3, and we can subtract it from 180. We get they all add together to be 180. Now, if I took, say, I'm just going to pick tangent of angle B. Well, tangent would be what? Opposite over. So we'd have 2 over 3. We would apply tangent inverse to both sides. And tangent inverse of tangent of B is just B. Now, if we take tangent inverse of 2/3, second tangent inverse of 2/3, we get 33.7. We get the exact same thing. Questions on this here? So here, we're looking for side length F, angle E, and angle D. We're looking for the missing side, which in this case is still the hypotenuse, and the two missing angles. But if we want to find the hypotenuse, we can use Pythagorean's theorem. A squared plus B squared is equal to C squared, yes. So our two side lengths are 20, so we'd have 20 squared plus 21 squared is equal to the hypotenuse squared. Now at this point here, we could do 20 squared plus 21 squared in the calculator. 20 squared plus 21 squared, and get 841. Yes. So 841 is equal to the hypotenuse squared. We would square root both sides. I'm feeling and the hypotenuse is 29. So we found one of our three measures. Now we need to determine if we want to find the measure of angle E or the measure of angle D first. Measure of angle D. Now we need to determine if we want to use sine, cosine, or tangent. We can do sine, so sine of angle D. And again, sine is opposite over the hypotenuse. So the opposite side to angle D is 21 over the hypotenuse, which is 29. To find the measure of the angle, we would apply sine inverse to both sides. And sine inverse of sine of angle D will just give us the measure of angle D. Is equal to -46.4. And to find the other angle, we can. So we can add 46.4 to 90 and get 136.4. We can subtract it from, guys, we can subtract it from 180. And we get 43.6. Yes. Both are good because it is side length DE. One of the kind of with triangles, the way that we label the sides are going to be, because we use ABC normally as standard, and the angles are considered capital letters. That's why if you've noticed most of these here are, so here DEF. Also in that standard notation, the sides across from them are considered to be the lowercase of said angle. So here we could call it DF or lowercase e. Here's lowercase f, and this is lowercase d. It's another way to label them. That's a good question. Any other questions on this here? does it make sense that these two angles are very close to each other? 46.4 and 43.6, that they're very close in the overall measure. Because what are the sides opposite those two angles? 21 and 20. The two sides are close together, so the two angles should have close measures. Because we've covered already that the biggest side is opposite the biggest angle. The smallest side is opposite the smallest angle. So if two of the side lengths are close to the same length, the angle should be pretty close to each other as well. Do we feel comfortable with these here? Yes. If that is the case, I will let y'all work on the rest of the assignment here.
Thank you.
Welcome. I do not have water, but I do have soda. By the way, guys, on number 17, you might need to go out a few decimal places for the measure of side length Z.